Hello, everyone. Welcome to Ease of Going from Art to Part with Eiger. We really appreciate you joining us today. In today's webinar, you will learn that additive manufacturing is changing the world. Software is the brains behind 3D printers. Going from CAD to part is a simple 6-step process. Default and custom settings balance simplicity and specificity, and what the process actually looks like in action. We have 3 members of the Markforged team here today to take you from art to part with Eiger.
Hi, I'm Kevin Smith. I'm a field application engineer based out of the Detroit area in Michigan, and I'm happy to be here today and show you all Eiger.
Hi, I'm Shelby McLeod. I'm a product manager here at Markforged, and I work on our software Eiger, which we'll be walking you through today.
And I am Mark Levitt. I'm a senior product marketing manager at Markforged with a focus on software and security. Adaptive manufacturing, which uses 3D printing to create objects by adding materials layer by layer, is changing the world by making it possible for anyone, anywhere, to make their own tools, spare parts, and other objects. Look around you. You will see objects that used to be manufactured using traditional CNC manufacturing, machining, or injection molds. Now, they are increasingly being 3D printed in less time and at a lower cost, and at the point of need. For many parts, it is no longer necessary to wait weeks for it to be delivered from a factory in a different part of the world. Of these 10 objects on your screen, all were 3D printed except for one. Can you guess which one was not 3D printed? If you guessed the house, you are incorrect. This is actually a 3D printed concrete house built by Habitat for Humanity in only 28 hours in Virginia. The only object made using CNC traditional subtractive manufacturing is the auto part in the top left corner. The 3 objects on the right, a phone holder, a handle, lever, and cable connector, were 3D printed using composite materials. The remaining 5 objects, a heat sink, impeller, sprocket, actuator housing, and air intake, were 3D printed using metal materials such as copper, steel, stainless steel, and Inconel, which is a nickel chrome alloy. Post-processing by sanding or plating can make any of these look like the CNC machine auto part that was not 3D printed. Here's a time-lapse video of what a 3D printing looks like for a drone unibody. The printer knows nothing about drones. It needs to be told what and how to print the part. Software is what we use to tell the printer everything it needs to know, including what part to print, how to print the part layer by layer, what materials to use, where to add supports if they're needed, what type of infill design to use if the part isn't being printed solid, where to add reinforcement if needed, what surface finish is needed, and how many parts to print at the same time.
Once you have a design for your part, going from CAD software to 3D printed part is a simple 6-step process. So first you export your part from your CAD software, then import it into Eiger, the Markforged software. Then you will slice it. So that is done again in Eiger, figuring out those paths layer by layer. Then you can configure any settings that you might want to change, and then lay out your parts on the print bed if you're creating multiple, and then print. And how much time and effort you need to put into each of these steps will depend on what you decide about those settings. So if you decide to go with default settings, which are based off of what works for most parts, the 6-step process can be completed really quickly and easily in just a minute or two. If based on the specific part you're printing, you decide that you need to customize the settings, then some of the steps will take some time, but may produce a better result for that specific part.
Awesome. Thanks so much for that. Let's go ahead into the demonstration now of Eiger. Let me go ahead and share my screen here. Great. So yeah, what we're going to do today is we're going to take a look at exactly what Shelby just talked about, and that is how do we go from importing a part to slicing a part to printing a part with the Eiger software. Right now, what we're looking at is the library view of the software. And in order to Mark, if you could take back over again and show that picture of the demo part. I totally forgot. We need that demo part shown up here just so everyone has an idea of what we're talking about today.
Sure, no problem.
Perfect. Thank you. I missed one step. Sorry about that. So what we're looking at today is this hybrid gripper. It's a metal composite hybrid robotic end of arm tool. And it's used with the system integrator in an automated robotic cell. So this application goes by many names such as grippers, end of arm tooling, end effectors, fingers, pick and place, etc. The idea here is that these are used on the end of a robot arm to pick up an object and move it from one place to the next. The interesting thing about this application in particular is that we're using our composite printer and we're using our metal printer in order to produce two separate pieces for this assembly. And the reason we're doing this is because it has some functional requirements such as high stiffness to deliver for the clamping forces, as it's going to pick up a part that could be heavy. It's also going to need some wear resistance. That's why we have the metal pad at the end of the finger. And then it also needs to withstand some heat because the part that it's picking up is going to be hot, around 200 degrees Celsius. So as we move from one operation to the next, we want to make sure we have some heat resistance, and another reason why you might want to throw a metal piece at the end of your robot gripper. But we'll talk more about the robot gripper and some other functionality of this as we go through the demonstration. Let's head on back over into Eiger. I'll share my screen again here. Awesome. Great. So I would like to say that Eiger could be as simple as 3 steps. And I've gone through this a number of times, and I think I can prove it out right now. So if we import our file, granted, we've saved out our STL file from our CAD software already. What we do is just go to import STL. We pick our part. We import it. Now, the one thing you might need to do here is set up the part so that it's on the build plate the way that you want it to print. Orientation matters in a lot of cases. We'll talk about this a little bit more in a moment. But bring in the part and then use the default settings. Don't touch anything. And we'll go ahead and hit save. What's happening now is Eiger is sending information to the cloud. Eiger is a cloud-based software, but it still has a ton of security. We're ISO 27001 certified. That's how much security we have. Go to markforged.com or type in Markforged plus security, and you'll find a ton of information on how secure Markforged's platform really is. Next, after we hit save, it goes through, like Mark was saying earlier, does all the tool pathing for the 3D printer, and we can directly go right into print. And this is where Shelby was talking about throwing the part on the print bed. We can actually see the part on the print bed. We can zoom out and get some great perspective just as to how big this part is and what it looks like on our actual 3D printer. And then we hit print. So I think that's 3 steps, but we could also make it a little bit more the way we want it, more user configurable if we want to. So let's go back in time. We can either hit the back button on our browser because Eiger is a browser software. We run this from Google Chrome. You can backspace through everything that we just did there. It won't undo anything. So it's going to save your settings that we have right now with this part. But we could backspace through or go back through the browser window, or we can just go right back into library by clicking this button up here. Finding your part in your library. By the way, the library has different sections to it. We could create more folders, add parts to specific folders. Right now, we just have this set up as a basic default account to keep things simple. But we'll go back into that part. We'll just click on that part, open it up. Everything is the way that it was before. Nothing's changed. But we might want to make some adjustments to this. So let's talk about that in a second. But first, let's take a look at the left side of Eiger here. There is a part details window, and the part details window is going to give you information like the size of the part, the time that it takes to print the part with your current settings, obviously, and then the part mass. Another thing to think about is the plastic volume. How much material are we actually going to use to print this part? And then what is that going to end up costing us? If you want to do this right now, you can go to eiger.io and you can set up your own account and bring some of your own STL files into Eiger and start mathing things out. Like, what is it going to cost me to print this part? And figure that out right now if you wanted to. So next, we'll go to the settings. Like we said, we can get more intricate with exactly how we're going to print this by using the settings that we have here. Let's take a look at the settings, the part settings tab over here on the right. Real basic here. We're going to keep it real simple. We have our material drop-down menu. This is where we can choose which material we're going to print with. We also have reinforcement material. Markforged has a unique capability where we are able to add in fiber reinforcement to our parts. This is a secondary process, a secondary printed material that goes into the part. Carbon fiber, Kevlar, fiberglass. These will make your part super strong and keep it lightweight. So in one application, this one today, we're talking about carbon fiber. Carbon fiber is a great reinforcement material to use when we're looking to replace aluminum or other metal parts with our 3D printed onyx, our base material, and carbon fiber. So keep that in mind. We also have our printer type we can choose from here. These are just some different options that you can use when you're getting started. Next, we have layer settings. We can change the layer height of our part. We can change whether we're using supports or not. Notice everything in here is a toggle switch, a slider bar, or a drop-down menu. The way that we work at Markforged is we have teams of engineers, hardware, software, and materials. And we all work together to make sure we have the best, easy to use product and get you the right part every single time. So it should be as simple as picking drop-down menu items or selecting slider bars. Let's go back into the reinforcement material here because I want to change this so we can look at the reinforcement being added to this part. So with carbon fiber selected, we're going to go into the reinforcement dropdown and we're going to add reinforcement or carbon fiber on every single layer. We have a few different choices to pick from as far as whether we're going to go with an isotropic back and forth raster style motion or a concentric follow the part edge style motion as how we add in this fiber to the part. Now, this is something that we can adjust. And if you need to understand a little bit more about what each of these options do, you can select the name that's associated with that drop-down menu, and it will give you a little tooltip there. So let's go ahead and save the changes that we've made. Remember, we're adding in carbon fiber to give it strength of aluminum, and we're going to go through the slicing process again. Once again, what's happening in the background here is the Markforged Eiger software is tool pathing the movement of the machine, where the material is going to get laid down. And now we're going to have some carbon fiber. Where do we see this? The internal view. The internal view is like an X-ray into the part. It shows us the internal process that's happening on the machine, how we build this part up. We can see our supports. We can see our internal triangular infill or solid infill. Keep in mind, with 3D printing, we can lightweight things. It's not like a plastic injection mold. When you inject the material, it fills up the entire mold and you have a solid part. We can print solid if we want to, but we can also go with the triangular infill, which will lightweight the part further. So what we're seeing on screen right now is a lot of blue. That's the carbon fiber. That's the color we've chose for carbon fiber with the Markforged Eiger software, and purple, the supports. We can go through and take a look at this in the 2D view, once again, in an X-ray view, see exactly what's happening on each layer, and just verify things are gonna work the way that we want them to work. We have the fiber in the right place. And we could literally go through and change every single layer of fiber if we wanted to by using these options up here on the right. I'm not gonna get into that right now because this is a whole separate subject and we have Markforged University for that. If you want to understand a little bit more about what fibers to use, when to use them, and how to use them, take a look at Markforged University. It will give you some great tips on that and a great learning experience as well. So I'm going to go ahead and revert the changes I just made here. I'm not going to save those changes. And then we're going to go into the build view. Once again, click print, takes us to the build view, and we've got our part in our 3D printer ready to go. On the upper left side here, this is the build details. Why does it look kind of the same as the beginning, but a little different? It's because this is what we call a build in Eiger. We can add in more parts. So if I wanted to make 3 gripper fingers, most of the time, your robotic end of arm tooling is not just 1 finger. You might need 2, you might need 3. We can go ahead and add in more parts using the add parts option over here on the right. Now we've got 3. Notice they automatically nested on here, so they're in the perfect position to hit print. We can go ahead and hit print now. It's going to take you to your option to print, and it's going to tell you, hey, this is the plastic volume, this is the fiber volume, this is how long it's going to take to print this. Do you want to print it now, or do you want to send it to your print queue? So that's composites. We started with just a simple 3-step process, boom, 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 or we got way more intricate by adding in carbon fiber, seeing how it's routed in the part. We could have changed some things there, and then we added multiple parts to our build plate. So we've changed some things with that last example there. What I'd like to do is go through one more example with you. Let's take a look at the little gripper piece of this end of arm tooling, which is that metal piece. We're going to go ahead through the whole process one more time. Let's take a look at this whole process one more time. Import STL. We're going to select our metal contact piece. Import that into Eiger. This is where we're going to set up how we want to print the part. We're going to select this bottom face right here. We could use the manual rotation option to rotate this around, however we want to rotate it. Then remember, we're working with metal now. What's going to change? Our material type. So we'll go up here to the material drop down and we'll select 17.4 stainless steel. You can see all the other options of materials that we have here too. 17.4, it automatically chooses a furnace and a printer type based on the material that we chose. The Metal-X system is a 3-part system: printer, wash, sinter. Something to look into if you're interested in printing metal. We won't get into all the details of that right now. Notice we're also getting some messages down here at the bottom of the screen, and you'll see this too if you load up a Eiger instance and try to run through some metal parts. It's just letting you know that, hey, you don't have a MetalX system in your organization, which I'll show you our organization here in a second. But if you did, you would have that option to print with. We'll go ahead and just run through the calculation of this part with our default settings. And we'll take a look at the part details. They're going to look a little different this time because now we're looking at a metal part versus a composite part. I did want to talk about something else when we look at this part, and that is this pattern on this piece. It's a knurling pattern that was designed in. The nice thing about 3D printing is complexity is free. It may take a little more design time, but think about CNC machining this part. It's going to be a lot different of a beast, right? A bigger animal to handle printing all these in here. You might have to use a V-bit tool to get it in this curved shape in the first place. You're going to have to remove a lot of stock from the CNC machine. We also have some internal channels in this piece too. So 3D printing allows you to add complexity to your part without any added cost. Let's move over to the part details. It gives us the print time, wash time, dry time. Once again, this is a 3-part process. We print, wash, sinter. And then we also have our metal volume and how much it's going to cost to produce this using the 17.4 stainless steel material.
Just an interruption. If anyone has any questions as we're going through this demo, please post them in the Q&A. Thank you.
Thanks, Mark. Absolutely. I know we're going to have a Q&A section at the very end too, but absolutely. Next, let's go to that print view one more time. Remember, this is the build view within the Eiger software. It's going to show us our MetalX build plate. And if we zoom out, we can get a perspective where we can see the actual entire MetalX system on screen. And over up here on the right corner is where we can see our printer type. You can see MetalX is grayed out right now because we don't have a MetalX within this organization for this demo of Eiger. But we have our estimated print time, stainless steel volume of material, and then the material cost. And if we wanted to, we could add in more parts here, and we could print 3 of these if we needed to, just like we were with the composite parts. So, or we could export the build too. If we wanted to send it to somebody that we knew had a MetalX system, we could do that. Yeah, so like Mark said, any questions so far? I know we've covered a lot right now. Yeah, we can go further here, or we can answer some questions.
And I know that one common question is, the cloud is great, and for some of our parts, we can use the cloud. What if I need to work completely offline? Is that an option? And in fact, I would say a minority of our customers do use our offline Eiger software, which is 100% offline, which does not require any internet connection from the computers or the users that are accessing the slicing, the part storage, the slicing, and the printing. And they can directly print via USB or using our LAN connector capability to connected printers on their private local area network. So we definitely have an offline capability. Most of our customers see the power of the cloud to be able to be connecting to any of their printers anywhere in the world, wirelessly, over the internet, and doing so, with the power of the cloud. And we also, the system that we have is a self-learning system with over-the-air updates, which is informed by anonymous data that we can gather in the cloud to make sure that prints are successful, and we can tweak and adjust things. And we've been doing that for over 8 years now.
Yeah, Mark, one thing I'd like to point out, you got a couple points there that I wanted to refer to. Number one, we didn't talk about the dashboard, right? There's a lot of intelligence behind Eiger. It's your Markforged hardware management system. So it's not just a slicer. We can take a look at the dashboard here. The nice thing about the dashboard is it's going to give you insight into what your users are doing within your organization, how much material they're printing, how many printers you have, which ones are up, which ones are down. These are the kind of things that are in the free version of Eiger that you can access from the cloud right now. So very intelligent. The other thing is too, once again, it's cloud-based, it's internet-based. So you want to kick off a print from your house, great. You want to kick off a print on a printer that's across, the globe, go for it. You've got those options there. So, as far as the way that Eiger works, it's a management software as well. And like Mark was saying, we can build on this. We have the way to scale up Eiger to more of a global fleet management system. And the dashboards is one piece of this, but it gets bigger as you grow as an organization. So 3D printing can become a very powerful tool for you globally.
I see a question in the Q&A here asking how you would obtain the material. Is it supplied by Markforged? So I can say yes. So we produce all of our materials and build our software and our printers. And so something that's really great about that ecosystem is when you're buying Markforged, you're not buying just a printer, you're buying the whole digital forge, which includes all three of those things. And that's actually part of what makes us be able to have such an easy kind of like seamless process in Eiger that Kevin just demoed for us, because we have control over our printers, we have control over the materials. We can make those settings so that you don't have to fiddle with a bunch of different settings. We know what's going to print best on our printers. And so we just give you control where it's most meaningful to you, and we take care of the rest to make sure you get great quality prints.
And we are continuously releasing new materials. So just this week, we released what we call precise PLA in multicolors. Most of our prints have historically been in black with onyx as the base nylon material. We've had a nylon white as well, but it's been primarily black for industrial commercial purposes. But we have introduced precise PLA with lots of different in lots of different colors for prototyping and other uses. One question also has come up, Kevin, is can you pause a print for various reasons to bring in some tweaks? I know some people like to insert magnets or something in the inside of the print. Can you describe that process?
Yeah, absolutely. Yeah. So we would go into our internal view of our part, and we have some options in there where we can add in pauses for inserting hardware like magnets or maybe nuts that will be an attachment point for an assembly of parts. I like to give just a little bit of information at a time, because 3D printing really takes on, it's a big animal. It takes on a whole new, creative mindset when you get into 3D printing. But yeah, a lot of our customers are doing some pretty intricate stuff with this. So if I wanted to add in a pause, I could select any layer in the internal view here and just choose this option, pause after a layer. And what's going to happen is it will pause the machine. And whenever something happens on the Markforged equipment, it's going to send you an email notifying you that your print is paused. And then you can walk over there, drop in your nut or drop in your magnet, whatever it is that you're placing into the part there. Yeah, that's how you would do that, Mark. Great question.
Another question is, do we have the option to design a part from scratch, I assume within the Eiger software? And related to that, can we manipulate the size of the part? And can we produce our own parts? Could you kind of describe the interaction between CAD software versus Eiger and what changes you can make around size and other things within Eiger?
Absolutely. Right. So the CAD side of things is a separate entity. So whatever CAD software you're using, we stay agnostic to that. And all you'll be doing is using your CAD software to design something, save out an STL file. And that's what we were doing at the beginning when the library view, we brought in an STL file. So CAD's separate. What can we do as far as like part size goes here? We do have an option in our settings where we can use this scale function. We can scale up the part up or down. If for some reason you got the part in imperial units versus metric units, you can change the units here as well. So those are a couple different options we have there. And I didn't want to go through all of the options because there are quite a few options for being such a simplistic software. You can get really into the weeds there for sure if you need to.
Someone asked a question, where's the name Eiger come from? And does anyone have a history of that name?
So the software, and Shelby might be able to expand on this a little bit. From my understanding, we name all of our software after mountain ranges. So as we have internal offerings that we're working on, we have a mountain range name associated with them. It's just like Apple, really.
Thanks.
All right, I see a question we have here. Can I start a print if the material is not enough to finish printing the part? Is it possible to refill the material in the middle of the print? Yes, absolutely. So again, like Mark mentioned with or like Kevin mentioned with the pausing, if your printer runs out of material, it will just notify you, and then you can go and refill that material in the middle of a print if you need to.
And you could even put in a pause if you anticipate you're going to need to replace the spool. You can set a pause prior to that point, and then it'll stop, and you can go in and do that. So you can do it either in a planned way or an automated way.
Yeah, and the nice thing about understanding how much material is being used in the part detail section over here, just about a month ago, I was working with a partner of ours, and we wanted to get this part so it was just the right size so that it only consumed one spool of material. So we had some tweaking that we did in our CAD software. We'd bring it into Eiger and slice it, make sure that we got the part size just right, because you want to be there when you're changing over a spool of material. In most cases, that's what people are looking for. But this size part here, this is small enough where you could fit a lot on the build plate before you're going to go through a spool of material. So a little different. You've
showed using Eiger for both a composite parts with and without fiber reinforcement, as well as a metal part. So obviously the software can handle both. The question is, does Markforged have a printer that can print both metal and composites today?
Well, currently that's not in our offering.
Correct. Yeah, we have the separate metal X system. We have desktop industrial composite printers. And that currently, if customers need both of those materials, then they need both types of printers. We do have partners in our channel that act as service bureau. So if you're primarily printing in composite and you occasionally need a metal part, you could rely on a partner to print those metal parts for you, or vice versa. Absolutely. And one thing to touch on with the metal is the triangular infill with the metal. It's super important to understand that when we're printing 3D, we're usually running with triangular infill. You can print solid with metal if you wanted to. You could print solid with composite, but if you're trying to impact your weight on the end of arm tooling, then print that metal piece with triangular infill and reduce the weight of that part. It's very impactful. There's a question about, can you elaborate on the accuracy and quality of the printed and sintered surface finish for metal parts? If you want a high quality finish, or I should say a higher quality finish, does it need to be CNC machined and polished by hand, or what do some of our customers do to post process their metal parts? Yeah, as far as
the metal finish on our parts go, what we refer to that metal part is it's a cast-like part. So just like as you would see in your normal 3D printed parts, depending on the layer height you choose, you would potentially see some of that, the layer height ridges or cusps, as some people refer to them as. But that's a minor thing, especially when we're talking about a case like this. Now, if you need a surface finish like a CNC machine part, you can CNC machine these parts afterwards. That is an option. We could also adjust the thickness of the walls or the shell of the part to enable you to have that stock that you need to remove for the CNC machining process. But a lot of our customers are CNC machining these parts on the faces they need to, or they may be drilling, tapping, reaming, things like that to clean up surfaces. But yeah, the part will come out in more of a cast dimensional shape. But the other thing about this too, I always like to touch on this, is the machines that we make are extremely stable. They're made with machined CNC parts and everything. It's a much more sturdy machine, so it's way more reliable. And if you wanted to adjust something in your CAD, you would see that adjustment come out in the metal part. So if you know, like, hey, I need a little more material here or a little less here, or I want to tweak this just a little bit here and there, you can do that in your CAD and you will see it come out in the end results from the sinter oven. And typically we're within plus or minus 1% is a good estimate as far as the overall dimensional accuracy on metal parts.
And for tooling, I mean, customers are really impressed by the finish of our parts, both on the metal side and the composite coming right off the printers, and obviously with the sinter for metal. But there are customers and their partners who use sanding. There's chrome and other plating that can be done with any of our parts. So again, that's definitely possible to have an end-use part that can be put in an automobile or an airplane and have that appeal.
Absolutely. Yeah, and our composite parts, we're probably more like 5/1000ths of an inch, or 20, even down to 20 microns. Like there's actually down to 50 microns. Sorry, there's a much more higher accurate part coming off this X7, the industrial series. It has a laser micrometer on it, and it's just a little bit more of a robust machine than our desktop printers because of the laser micrometer and some other configurations that we have in there. It's bigger, so it needs more stability. So we've added some more, metal parts to it and things like that. And there's also some extruder improvements and things like that we've done to the industrial series versus the desktop series. But we can be usually within 2/1000ths to 5/1000ths of an inch. But it's a lot of it's geometry dependent. And but yeah, we have more information on that too on our website. If you look for our design guide, the Markforged design guide, composites and metal, we have design guides for both of those.
There are a couple of questions that relate to the design file. Does it have to come from a CAD package? Can I use something like Blender 3D? I think anything that can export an STL file, which is the industry standard for the kind of file that 3D slicing software like Eiger uses or ingests. So anything that can export STL. We currently don't import CAD files directly. That's something we have been looking at, but we do, and for the past 8 years, we've relied on having the design process happen in a CAD or similar type of software, which can then export to STL.
I see another question here. What is the best way for my mechanical engineers to learn how to design products to maximize the benefit of additive manufacturing or the specific technologies of Markforged printers? So yeah, as Kevin mentioned, we have Markforged University, which is a great course that really goes into not just using Markforged system, but also designing for additive manufacturing, what kind of the benefits are and how to maximize those things. So highly recommend that as a way to really understand how additive manufacturing can be a benefit to you.
And there are universities around the world. There are centers like Print City in the UK that have our and other additive manufacturing systems in-house. So look to your local universities to see where there is a 3D or additive center, and definitely get some hands-on experience. But just to do this virtually, create your own free Eiger account, and you can do everything but press that print button. So you can import your design files. You can see what the time would be. One of the questions relates to how long does the printing process take. You'll be able to actually see that for your part or for sample parts. If you don't have your own parts yet, look to sites like Thingiverse and other places where you can find STL files for common objects, things that you can use in your office, in your home, in your factory, and so on. So definitely, there's a lot of things you could do online virtually before committing to bringing a printer or a printer wash and sinter in-house. And again, there are lots of Markforged partners that will take that build file, print file from you and actually produce the part for you.
Yeah, Mark, and that's a really good, as far as the process time goes, we get these kind of questions a lot. The best thing to do is to get with a partner, and you can contact us to find a partner if you need to. But I'm an application engineer, and like the majority of what I do is helping people understand how long things take, what the process looks like, to make sure that the investment you're making makes the most sense for what you're trying to do.
There's a question about differences between some of the Markforged printers, and each one has its own supported materials. Each one has, if you go from one class to the next, from a desktop to industrial, as Kevin said, different build volumes or sizes. Also, there's some printers that have a turbo speed that is a little bit faster than some of the other models. So definitely look to the specific details of what kind of part you're producing, what kind of fiber reinforcement you need, and then we can help you figure out, along with our channel partners, which devices would be most appropriate for you. Let's see, any other questions you want to cover? We're nearing the end of our time. Let's see. Question: is it recommended to print different parts at once because settings for one part may not be good for other part? I guess the question is for Kevin. When do you decide when to put multiple parts on in a build versus doing separate builds? What are the considerations there?
Right. Yeah, the layer height does affect that. You want to work with. You could put multiple parts on there that have the same layer height. Another thing to think about is the configuration, what reinforcement material they're using. We do have 2 print nozzles. We do have 2 extruders on the machines that have the fiber option. And so therefore, that process is you've got 2 materials, and those 2 materials will be in your machine. So it would make sense to print parts that have those same materials at the same time, and not be having to change materials out in the middle of the build process. So that's how we have it set up. Is you want to run with the same materials and same layer heights.
There's a question about some of the differences between choosing between Kevlar and carbon fiber or fiberglass. That relates kind of the textile strength, whether it's an impact that you're looking to protect from, or the elasticity of stretching apart and it not breaking. So each one of those has its own strengths. I would say our carbon fiber is probably our most popular reinforcement type with fiber. But again, depending on your use case, we or partner can talk you through which is the best fiber to use for your specific parts. Some of our printers support only one type of fiber. Others support all of them. So again, that's a consideration for based on your parts and what you need. We can provide a solution for you. There's also a question about infill. How do you choose between the different kinds of infill? I know that we've introduced new infills. Why do we need more than one? What are some of the differences between them? I think you touched on that, but is there any more thoughts about that, Kevin?
That's a really good question. I've typically just run triangular, and I've run a solid fill. And really it depends on the application. So once again, there's a new one called gyroid, right? And gyroid's kind of a big deal to some people. It's really cool, but I think it's all about getting the biggest bang for your buck, depending on the application. And gyroid might get you that bigger bang for your buck than the triangular infill. But I think the triangular infill process is the fastest, and there may be some reasons like that why you might choose one over the other, but typically I've stuck with triangular and solid.
Thank you. There's a question about, does the balancing more speed or less print time within Eiger? We do have some settings that we can adjust that would make it print faster. What are some of the considerations there? What are you giving up if you choose the faster printing versus the standard or slower printing?
Well, okay, so surface finish would probably be the biggest thing to consider when choosing different layer heights. We can go on the industrial series, we can go from 50 microns up to 250 on the X7 industrial unit, which is sitting behind me right here. So there's a turbo print option that's printing at 250 microns. A lot of industrial printers out there that's the major layer height they're using, but we can go all the way down to 50 microns. So if you really want like super sharp surface finish, almost like an SLA type 3D printed surface finish with an FFF style machine, we can get down to 50 microns, and it's very hard to see the layer height on there. So that would be a really good reason why you would want to go down to 50 microns if you want a really smooth surface finish. And yeah, like it's an exponential difference. If you're going from 100 microns down to 50 microns, you're probably going to double the print time. That something it's really worth taking into consideration with what you're doing and what makes the most sense there.
There's a question about Onyx. What is benefits, qualities, and applications? Again, it's been our base composite material or nylon material from the beginning. It's a fused filament fabrication with little pieces of fiber inside and mixed in with the nylon. So even if you're not using fiber reinforcement, you do have very small pieces of fiber that strengthen Onyx. So it's not just nylon; it's a fiber fiber enriched a nylon, and so which is different from having continuous fiber reinforcement that you can add as well to your part. So Onyx is a material that can be used in industrial commercial applications because of its strength, and it is a high quality material that has been our primary base material on all of our composite printers. As of this week, we have introduced, as I said, the precise PLA that is designed more for prototyping. It does not PLA just doesn't have the strength of Onyx, and so we are talking with customers who are anticipating using the PLA for prototyping purposes, and then when they're ready to produce that final tool or end use part, on their composite printers, they would then use Onyx with the fiber reinforcement.
The other thing that's really nice about Onyx is it's extremely durable. It's going to flex before it breaks. Like it takes a lot to break nylon, and so what you can do is have that strength of the nylon, that flexibility with the nylon, but then you can add in fiber reinforcement like carbon fiber or Kevlar if you need impact resistance. And the other thing about the Onyx material is its chemical resistivity there's a lot of chemicals that can work with nylon without causing any catastrophic failure. It's not going to wear away at the material. So nylon is a great industrial material.
Question about our printers themselves. Do they go to sleep by themselves? Do you need to power them down? And most of our printers are on 24/7, and they are low energy consumption. Kevin, do you see or hear your printer kind of going to sleep mode if you're not using it?
We don't have a sleep mode for it per se, but the temperatures, all that adjusts automatically. So once the part's done printing, the heat goes off, gets cooled down by some fans on there, and then the heat goes off. So really when it's heating in building is going to be when it's consuming the most energy, but I mean, it's extremely low energy. If you wanted to reach out to us, we can give you like actual energy ratings on our machines, like how much energy they'll actually take to run. And in idle mode, it's ridiculously low. The X7 and the desktop units, even the Metal X printer just plugs into the wall. So it's that lightweight on energy.
We did have a question about supports, and we talked about how you can either turn them on or off. When you turn them on, it's for your basically the entire part. We have been exploring or planning to support the ability to be more selective about where in your part to have support. So definitely keep an eye on markforged.com and for updates on that.
I see a question here we have about overall print time. So the gripper part, Kevin, you were showing being 7 hours. What were the times for the kind of post-process, so the wash and sinter? If you could pull that up.
Yeah. 1 second here. I can, I guess, reshare my screen.
As you're doing that, we did introduce a kind of a next day metal capability. So depending on the part, you can have a part that starts printing today and it'll be done, fully done, ready for use, by tomorrow. I think it's a 28-hour time span. So, we're not talking days or weeks. We're talking about, typically within the next day time, depending on the build volume and the complexity.
Yeah, absolutely. And that's due to some special configurations that we've created. The nice thing about the Metal X system is, well, any Markforged hardware is it keeps getting smarter. Like Mark was saying earlier, we have over-the-air updates. That's a huge benefit to having a cloud platform, is that it literally gets smarter overnight. And we're not, these aren't going to get outdated and start collecting dust. And you don't need to call us to come and implement a new material or things like that. The Metal X system started in 2018. Now it's 2022. We are 2 times faster printing our materials than we were in 2018. And that was all just over the air updates. We do a lot of hardware engineering. We do a lot of material engineering and software engineering behind the scenes. And that's what makes it really special. So as far as the print time goes, we've got 6 hours and 15 minutes here. Wash time is 4 hours. Dry time is 1.5 hours. And then the sintering can be anywhere from, depending on the sinter unit itself, because we have 2 sinters, sinter 1, sinter 2. And depending on whether we're doing the express run, which is 17 hours, it can be anywhere from 17 hours to, I think, 27 hours is the longest run we have.
Great.
But that's just one part that we're showing on the screen right now. So printing is a 1-to-1 application, meaning when I print 5 of these, it's going to take 5 times as long to print 5 of these as it would 1. If we're going to put this in the wash station, it's a batch process. So washing 5 of these is going to take 4 hours, not 20 hours. Sintering 5 of these is going to take whatever that sinter time is. We're not getting exponentially larger based on the number of parts we're doing, only on the printing system. Hope that helps.
And with that, I think we've answered all the questions for today. Thank you so much to Kevin and to Shelby for joining me. And thank you to all of our webinar attendees today and those of you who will watch this in the future. Please reach out to Markforged if you have any other questions. Thank you. Have a great day.
Thanks.
Thanks.